Okay, if you remember last time, we wrote this whole program all from the beginning. Okay, we did not do any, say trial and error, because we had already seen or studied the data with small examples in previous sessions, and we created a pipeline. Okay, and we used two models. So the first model was regressor model, linear regression. We did linear regression using the linear model. Okay, and we tested, we trained the model with the data which we had collected. Okay, and then we saw the mean squared error value for the linear regression, which came to 8.755 something. Okay, and then we also found out the square root of the mean squared error, and that was 2.95. Okay, then we thought of implementing some other model and check whether we get a better prediction. Okay, if this value, that is of square root of mean squared error, if that is close to zero, then you can say that it is a better model. It should not be exactly zero, because if it is exactly zero, then it indicates that it is, the model is too perfect, and it is overfitted the, you can say, the data. Okay, it's able to predict each and every value to the point, which should not be the, you can see, case, because if I'm using my training data, that means the model has understood the training data so much that it's able to give you the exact value. Okay, that should not happen. That is what it is suggested. So this was the code which we had written. So coming back to this code, here it is. Okay, so we used decision tree regressor. Okay, and we made a call uh, to the fit function, and we passed two values, the prepared data and the data label. Okay, to understand this prepared data, how we got the prepared data and all, you can go to this content here. This is my prepared data. We had pre-processed it. Okay, we'll also see some more pre-processing techniques in one more program. I'll show you one more program where I'll show you normalization and scaling technique. Okay, now coming to the value, here we have got, let us run this one first of all. I've already run it, rerun the whole code. So restart and run all the cells. Let us do that. So I get the latest outcome. Okay, so this is my value as 2.95. Let us see what is the value for this variable tree underscore RMSE. Okay, so as you can see, it is 0.0, which indicates that the model has overfit the data to a very great extent. And that means it is, if you represent this in a curve form, that means my curve is touching each and every point. Okay? So if I can go to Google, just one minute. Overfitting in decision tree, you can say graph. Okay, if I see the images, I'll just show you the image, how it indicates that there's an overfit. Okay, if you look at this one here, or this points here, if suppose I have plotted the graph, or is there a better one? Yeah, I can take this one. Okay, if I refer to this example, overfitting, where's the graph gone? Yeah, fine. Now, if you look at this graph here, okay, where each point, this curve is, let us say, of your prediction which is made, and this line or the curve is crossing each point here. Okay, this indicates it's overfitted. Okay, this, I think, underfit, you can see, and this is again underfit because it's moving along this overfit. Okay, so if I have a value of 0, let us come back. Where was this? Yeah. So This value indicates that there's a overfit. Okay, it is, touching or crossing. The curve has all the points which are plotted on the graph. Okay. Now to overcome this, what we can do is we can make use of say the k-fold cross validation, wherein it features we are going to randomly split the training set into k different subsets or distinct subsets, which is also known as floats or folds. Okay, and then we will train it and then evaluate the model k times. Okay, we are going to pick up different fold for evaluation every time and train on the other k minus 1 folds. Fine. So to do that, first of all, I need to make smaller subsets. So let us do that. Now to get this, I'll be importing, say, from sklearn dot model selection. So model underscore selection. I'm going to import the cross value score. Okay. Now the cross value score will be used to get the subsets. So cross value score. Okay. And we are going to create some, you can say, the prepared data which we had. We are going to convert that into a number of subsets. So let us have, say, scores equal to cross value score into bracket. We had tree regressor, okay, comma, the prepared data. So prepared data, the data labels, and the scoring equal to the negative, you can say, mean squared error. So NEG, mean underscore, this underscore, guys, mean squared error. Okay, and your CV value is around 10. So I'm creating 10 subsets from this prepared data. Okay, and I'll just run this one. Okay, no errors. Now let us create another variable called tree regression RMSE scores equal to, now we are going to use the numpy, so np dot square root I want, so sqrt, this is the function of all the scores. Like before this, I would like to see the scores. So let me mark this as a comment and display the scores. Okay. Now, as you can see, we have got the new values. The scores are all negative values. So we will get the square root of, say, this will be scores, but because it is negative, I'll put a minus sign. So I get the positive values. Okay, so let us run this one now. Fine, and display it. This is not what is happening code. So I'm going to display the values of and check. Okay, so I showed you the previous value, and now this is my tree regression. You can say RMSE scores. Okay, this scores I'll be using it further for training it. So let us go ahead and check the mean of this, and that will be LIN. I'll store it here underscore reg RMSE scores dot mean, and you can go ahead and just check this out. Okay, what this is not defined. Did we define it here? Okay, I had not defined it, so 1 minute. The tree values, this, okay, I missed on something. Okay, so this will be, I have to first of all, scores equal to, let us do that cross value and implement the scores here. So we have scores equal to cross underscore value score into bracket. Now, instead of using that tree regression, the values which we had got before, we are now going to make use of the linear regression. REG values, comma, prepared data, the data labels, comma, and the scoring again equal to negative mean squared error. Okay, and again we are going to have a set of CV equal to 10 value sets. Okay, and let's see, linear regression underscore. Did we see the mean of this score? Okay, I'll make some changes here on top, but before that, let me complete this RMSE underscore scores equal to, now I want the square root, so yes, square root into bracket again, because it will be in minus, so scores will be negative, so I'm using minus. Then you can see scores, okay, and also print the mean. Now mean I'll print it on some other cell in the other cell, so I'll remove this one. Okay, these are the values. You can see, compare these values now. Okay, and here I can get the mean value. This is 3, but we have not got the mean value for the tree regression. So after this, I'll insert one cell. So let us insert one cell below. Okay, and after displaying the score, let us see the mean as well. So tree regression scores dot mean. So the mean for the tree regressor is 3.47 and linear regression is 3.07. That means linear regression model is better compared to the other one, decision tree regressor in this case. Okay, especially when we are using the k-fold cross validation, where we have a number of subsets of training data. So what we are doing is we are creating 10 subsets and using it in the model. Okay, so if I compare these two models now, you can easily say that the linear regression model is better compared to the other one, that is your decision tree regressor model. Now the other two more models I'll be showing you. The other model is your random forest model, which can be used here. Now in case of random, you can say forest model, we'll again try to find out this regressor, the squared, you can square root of mean square error, and then compare it, and we can find out which is the best one. Again, one more thing, please remember, I'll be using the subsets only. So I prefer using the k-fold cross validation feature, so that my data or the model is trained using different subsets of the prepared data or the trained data. Okay, so let us write the code here. So I'll just mark this as a markdown. Okay, and pass a command here. So let me write this as random forest model. Okay, so we are going to check this one. Now, first thing you have to import is the random forest regressor from sklearn. So from sklearn dot ensemble import random forest regressor. Okay, this is what I'll be importing. Let us write forest, create a variable for the model. We'll create a model and put it here. So random regressor. Okay, and we'll execute this. So fit and transform has to be executed. Dot fit. Okay, and what are the parameters we pass? We pass the prepared data and the data label. So prepared data, comma, the data labels. Fine, let us, then we'll run this one. Okay, so random forest regressor model has been created. And let us also make use of this, find out the scores using the cross value score function. So we'll create another variable regression CV, right? CV underscore scores equal to cross value score into bracket the forest regressor. So forest, last time we tried with linear regression, then we tried with the tree regression, the decision tree regression, and now with the forest regression, comma, prepared data, okay, comma, the data label, followed by scoring parameter equal to the negative mean squared. Error. Okay, and the value for CV is equal to 10. Okay, I can run this one. Okay, no errors. Let us see the scores now. So forest regression REG underscore, we are going to find out the square root of the squares. So, and by default, as I told, if you want to see the scores also, you can see it, the CV scores, and run it. These are the values. You can see these are negative values here. Okay, so let us now get the scores of forest regression. Instead of CV now, I'll create RMSE. Scores equal to NP dot square root. We have to find the square root of this into bracket, and because these are negative values, I'll use minus forest CV scores. Okay, so this and fine, and let us display the values and the mean. If you want, you can directly display the mean, and then we can compare it with the previous means which we got for linear regression and the other. Okay, this fit seems to be much better because you can see the values for decision tree was 3.47. For linear regression, it was 3.07. And for the random forest model, it was 2.54. Okay, so 2.54 is less and it's closer to 0. So if I have to predict the miles per gallon for this particular model, I think the random forest model will be better compared to the other two. Okay, so this is how you can do it. And the next model which we are supposed to see is the vector machine regressor model. Okay, so let us see that as well, and then we can move on to, let me pass a comment here, something in the chat, just 1 minute guys. So this is your support vector machine regressor. Okay, something in the chat. Okay, so what is the difference between all the three models? Okay, when we come with the modeling, the theoretical part, that time we'll discuss this. Right now, I was just showing you the coding part. So as I told you last time also, some theoretical part I'll show you, especially when we discuss all the three models. I'll show you the theoretical with pictures and everything. Okay, Advi? I just wanted to finish this particular example so that we can go ahead and start with some theoretical things. Okay, for vector machine regressor, again, I'll be using the sklearn package and import the SVR. S is for support vector machine regressor. Okay, so let us use that as well. So from sklearn dot svm, okay, svm import svr, the regressor. Okay, and I'll just complete this whole example. Actually, this example is too big. It also shows you how to create the model and create a web service, and through web service we can create upload this particular model, whichever model we come across which suits this particular case the best. We can create a web service and post it in the, okay, upload it in the website, okay, and use that particular model whenever we want to do any sort of predictions. So this example, I'm not going to go that far. Okay, I'll be stopping only on this model, the last model which I'll be showing you here, and then we will see some other things. Okay, because it is getting too lengthy. So let us create the fit it in the called the fit function, fit fit. Okay, into bracket the two parameters, prepared data and your data labels. Data labels. Okay, run this one. So my support vector machine regressor model object has been created. Let us see the scores. svm underscore cv underscore scores. Now everyone might be already aware of the linear regression model. Okay, we will try to see cross value scores into bracket svm regression prepared data labels, comma, the scoring equal to the negative underscore mean underscore squared underscore error. Okay, this is what I want, and I want the subsets to be 10. So CV equal to 10. Okay, run this and let us see the value now. SVM, and let us use the square root of the mean squared value of this CV scores which we have got. So I'm going to make use of this function scores equal to np dot square root, okay, square root into bracket svm cv scores. Now again, because these are negative values, I need to put a minus sign here. So I get run this and let us see the value now. If this is less than 2.54, then this will be the best model for my prediction. Okay, so scores dot mean. Okay, so I'm getting 3.08. So we can finally conclude that my random forest model is better, okay, for this particular type of an example. Okay, there are many more other models which are available, but because we are not going to cover all those. Okay, we will see in the theoretical part what are the different models available and try to understand it. But in the coding part, I am not going to cover those models. Okay. Now coming to this data, preparing data. As I said, we have already, you can see we have prepared the data in such a way that we scaled it and then we converted this into some better form. Actually what happens is, for all machine learning algorithms, okay, they completely depends on the data which is fed in as input. Okay, and that's the reason the most important aspect of machine learning algorithms models are especially your data. Okay, now if I do not feed the right data to my model or to my algorithm, it is useless, because it is not going to give me the right prediction or the right output. Okay, so in simple word, we can say that always feeding the right data, and that too, in right data means the data in the correct scale or the format, and containing some meaningful, you can say, features. Uh, Only then we can solve the given problem through you can say a particular model, or through a particular algorithm. Okay, so that is the reason why preparation of your data is the most important step in machine learning process. Now we have seen something, some data pre-processing here. Okay, especially when we are preparing the data for the to be fed in as an input to the model. Okay, there are two things which we have not seen in this example, which we have taken. One is, I think we had seen scaling, because I showed you scaling also, but I'll show you scaling with some other example. Now for that, we will create another file. Create a new file. Okay, and in this example, I'll be using some other, there's one PIMA, some PIMA diabetes data set is there, CSV file. This is not sorted as per the name, sorted as per the name, and okay. Okay, this one, the PIMA Indians diabetes.csv file. Okay, I'll be using this one. Now, these has, if you look at the file, the content of this file, there are some numbers available. There's no column heading, nothing. Now, to understand the data, again, you have to go through the data and understand each values, each column of it. Okay, we won't be going into that right now, because I just want to show you how to do, you can say, scaling and then normalization. These are the two techniques I want to show you. Now, we are not going to see what these numbers are and all that stuff, but there are some columns which will be given in the description, which I have already picked up, and let us write that code here. So, as I said, let me go to untitled pandas. This goes off, this goes off. Okay, this one. So what we will be doing is, first thing I'll be showing you what is data pre-processing. Okay. Now what happens is, after selecting the raw data, okay, like I just showed you the data is just raw. We have to actually use this data and prepare it in such a way that it fits into my model. Okay. And the model is able to process that data to give you some type of an output. So from the raw data, we are going to remove some training data, so that we can train the model, and then we can use some other data to get the predictions. Okay, so the most important, you can say, task in data pre-processing is training the machine. Okay, so training the model, you can say. Okay, so in the broad sense, you can say data pre-processing will actually convert the the selected data into a form we can work with. Okay, you can say we can feed to the machine learning algorithm. So we always need to pre-process our data, so that it can be as per the expectations of the algorithm which we are going to make use of. Now the first one, the technique for data pre-processing which I'll be showing you, is scaling. Now as you know, I showed you the pair plot. If you remember, I had shown you the pair plot, where the scale of each column differs. So you can see that your data set comprises of different attributes, or different columns, or different variables with varying values which are varying from different levels. Say the scale is actually varying, but we cannot provide such type of a data to your machine learning algorithm, and hence we need to rescale it. Now, data rescaling makes sure that the attributes are at the same scale. So all the attributes will having this same range, you can see, or the same scale. Now, generally speaking, the attributes are rescaled between the range of 0 and 1. Okay, so whether it is 100, 200, like I showed you the previous data, some value was, beyond 100, 200, 300. Some are ranging between 0 and 1. Some are in negatives as well. So these are different, ranges or the different scales of data, which has to be, you can say, normalized, or you can say scaled to a particular level. So usually you will find that this data which the raw data which we have, or all the attributes are rescaled into a range of 0 and 1. Now, in machine learning algorithms, like we have a machine learning algorithm called gradient descent and k nearest neighbor. Okay, these are the two types of algorithms which requires the scaled data. Okay, it need not be that, okay, all the algorithms will be requiring the scale data. Okay, for example, I am giving you, these are the two algorithms which require scale data, and there is a class which is available called min max scaler, which can be used to which can be used to scale your data or rescale your data between the given range. Now, the range which I said will be between 0 and 1. If you want some other range, you can also make use of that range as well. But truly speaking, the standard which whatever examples I have seen, they have scaled it between 0 and 1. And this package or the class, that is your min max scalar class, is available in this sklearn Python library. Okay. So the first thing, let us take this small example where we are going to open this file, which is of Pima Indians diabetes.csv file. But before that, I need to check out the different column headings for this. So there are around, I think, 8 to 9 column headings, which I'm not very much sure, but let me check that data again. So if I see that we had this one. Okay, so if I count this 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are around 9 columns, you can say, 9 headings we need to create. Okay, so I'll be creating some 9. I have already referred to the description file of this particular data. If you want, as I told you, there's a website called Kaggle where you get different sorts of, you can see, data sets. And along with the data sets, you also get the description of the data set, which will help you understand what that particular column is all about. Okay. So we won't be going into that. I'll just show you how to do the scaling part. So to do scaling, first of all, I need to import some packages. But the most important package which we import is your pandas and your numpy. So let us import that first. So import pandas as np. If you are not interested in the whole package, pandas, you can also import that particular, you can say, function or the class which you want to use. For example, if suppose I don't want this, let us say I want from pandas import. I just want to read that file. So what is the function name? It is read underscore CSV. So I can also do it like this. Okay. I can give it like this. So I can say from pandas import, okay, read underscore CSV. So it is going to read, import only that particular, you can see, function or the method or the class which is available under the package pandas. If I say import pandas, then it is going to import the full package. Okay, let us import, use the from keyword today. So I say from numpy also. I won't say numpy import. I'll be using one print option. So I want to use set the print option. Say print options, this one here. I'll be using this. And again from sklearn, I'll be importing the pre-processing. Import pre-processing. Okay, so we are going to pre-process the data. That's why we are importing this class. Okay, now to open the file, I can give file name. So file, let us say nm equal to. Now there's one more thing. If suppose your file is your CSV file, your data file is not loaded in the working directory. Now in that case, how do I actually open it? So I can create a path variable like this. Say path equal to, and I can give here say r single quote c colon. Let us say it is in c colon slash say Pima it's Indians diabetes. So diabetes dot csv. Okay, now this is how you can assign some path here and then use the read csv. So if I want, I can give df equal to read underscore csv into bracket the name of the file. So now because I put it in path, I'll give path comma, and the column names I have not used yet. So I can open it like this. Okay, so if I run this one, okay, it might give you an error because the file is, my data is not in this particular path. Okay, now this just to show you how, if I want to give the path, I can give it. Now because I don't have any, I have already loaded it in the current working directory, so I need to give only the name of the file. So I can give it like this. Okay, so let us, what is the error? So I've given path equal to Pima. I hope the names are right. Pima Indians diabetes. Let me go to the file and check it out the name again. Pima dash Indians diabetes.csv. Okay, the file name is right. Hello. Hello, ma. Let us open this file and create some name columns. So I'll have names equal to, I'll be creating the columns. As I said, I have already referred to the description file, and we have got this variables. We have preg, this is your pragma, then plasma, PLAS. Okay, then we have PRES, then we have skin is there, then we have the next one as test. Now these are all your column headings. What exactly they mean, you need to really go and check the description file. Then mass we have, PD we have, then we have the age column, and finally we have the class column. So we have this CLASS class. Okay, so we get this file, we have saved the file in this, I've given it to the path. Let us read this now, and along with path, I'll pass the names equal to the names column. The variable